Hi guys, this is Miss Igo. Welcome to my classroom. In today's video, I'm going to be introducing you to probability. We're going to be talking about some different terms and definitions and how to find the probability of events. A controlled operation that yields a set of results like rolling a die, tossing a coin, or picking a card is called an experiment. A trial is a single repetition of an experiment. The possible results of each trial are called the outcomes. And the sample space, denoted by S, is the set of all possible outcomes. Let's find the sample space for each of these experiments. In the first one, tossing a coin, the sample space, which I'm going to put in braces, would be, or the possible outcomes are going to be either, when I toss a coin, I could either get heads or I could get tails. So that's the sample space. Those are the possible outcomes. When rolling a die, I could either, and this is just, we're assuming this is a regular six-sided die, I could get a 1, 2, 3, 4, 5, or a 6. Sometimes, to help list the sample space, it's best to organize the outcomes in a tree diagram. Give the sample space for the number of boys and girls in a family with exactly 3 children. So if we were going to use a tree diagram, we could set it up like this. And we could divide this into 3 sections and say if we have 3 children, we could have all 3 boys. Or we could have all 3 girls. Or we could have 2 boys and 1 girl. So that's 2 boys and a girl. Or we could have 1 boy and a girl and a boy. Or we could have a boy, a girl, and a girl. In the same way, instead of having 3 girls, we could have 2 girls and a boy. Or we could have 1 girl and then a boy and a girl. Or we could have a girl, a boy, and a boy. So we could use this tree diagram to help us determine the sample space for the number of boys and girls with exactly 3 children. And now if we want to write it out in our braces, like I said, we had 3 boys. We could have had 2 boys and a girl. We could have a boy and 2 girls. We could have a boy, a girl, and a boy. We could have 3 girls. We could have 2 girls and a boy. We could have a girl, a boy, and a girl. Or we could have a girl, a boy, and a boy. And those are our possible outcomes. An outcome or a set of outcomes is called an event. An event, denoted by E, is a subset of the sample space. Let's write the indicated event in set notation. A die is rolled twice and the sum of the die is 5. We could roll a 1 on the first die and a 1 on the second die. We could roll a 1 on the first die and a 2 on the second die. We could roll a 1 on the first die and a 3 on the second die. And I'm going to go ahead and put the rest of these in and then we'll talk about them. Okay, so here are the rest of the possible outcomes. As you see, we started with 1 on the first die and 1 on the second die, and we go all the way to 6 on the first die and 6 on the second die. So we want to find the die, when a die is rolled twice, and the sum of the dice is 5. So the sum of 1 and 1 is 2. Okay, so we're trying to find the ones where the sum is 5. And I know that 1 and 4 add up to give me 5. 2 and 3 would add up to give me 5. 3 and 2 would add to give me 5. And 4 and 1 would add up to give me 5. Of course, any of these that start with 5, if I add anything to 5, that's bigger than 5. And then if I start with a 6, of course, that's bigger than 5. So the sample space of this event, a die is rolled twice and the sum of the die is 5, would be 1, 4, 2, 3, 3, 2, and 4, 1. Okay, let's write the event in set notation for this example. There are 5 people applying for a job: Sue, Juan, Trevor, Keisha, and Morgan. 2 people will be chosen for an interview, one of which is Keisha. So that means Keisha has to be in every pair. So the event would contain, I'm just going to use the initials of the people that would be in the set. So we would have Sue and Keisha would be one pair. Juan and Keisha. Trevor and Keisha. And Morgan and Keisha. If an event is equal to the empty set, then E is an impossible event. If the event E equals the sample set, then E is a certain event. Suppose a fair die is rolled. Find the requested events and then state if the event is certain or impossible. The event, the die shows a 4. That event would be rolling a 4. The event, the number showing less than 10, so this is on a die, and remember, we're assuming this is a 6-sided die, so we know that the numbers that are less than 10 are all the numbers that are on the die, which are 1, 2, 3, 4, 5, and 6. So those are the possible outcomes, but there's no way that we can roll something that is not less than 10. So this would be considered a certain event. And the last one, the event, the die shows a 7, well, that would be the empty set. There's no possibility there because there is not a 7 on the die, so this would be an impossible event. Set operations for events. Let E and F be events for a sample space S. Then E intersect F occurs when both E and F occur. So remember, when we see this symbol, looks like an upside down U, that means the intersection. So if we see this, E intersect F, that occurs when both E and F occur. E and F. E union F occurs when E or F or both occur. That is the union, and the symbol for union looks like a U. E prime or E complement occurs when E does not occur. That's the complement, and it's notated by this little apostrophe. A study of college students grouped the students into various categories. We have E, the student is under 20 years old. F, the student is male. And G, the student is a business major. Let's describe each of the following in words. E complement, that would be the opposite of E, or whatever is not in the set that describes E. So since E is students that are under 20 years old, E would have to be students that are not under 20 years old, or we could say a student that is 20 years or older. For the next one, this is F complement intersect G. So the complement of F, where F is the student is male, would be that the student is not male, or we could say that the student is female. Intersected with G, and G is the student is a business major. So to say this in words, we would say that a female student that is a business major. And the last one, E complement union G. Well, the complement of E, the student is under 20 years old, would be a student 20 years or older, unioned with G, which is the student is a business major. So because it's the union of these two, it could be a student that is 20 years or older, or a business major, or both. Disjoint events are two events that cannot both happen at the same time. This is also called mutually exclusive, which means that the intersection of the two sets is the empty set. There's nothing that both sets share. Can you toss a coin and get a head and a tail at the same time? No, the two are mutually exclusive. They are a disjoint event. Let S, the sample space, include 1, 2, 3, 4, 5, and 6. Let event E contain 4, 5, and 6, and event G contain 1 and 2. Are E and G disjoint events? Yes, the intersection of E and G is the empty set. There is nothing in common between E and G. So the intersection of E and G is the empty set. Therefore, these are disjoint events. Probability. Let S be a sample space of equally likely outcomes, and let event E be a subset of S. The probability that event E occurs is, the way we read this is the probability of the event is or equals the number of outcomes in what you want to happen, whatever the event is, divided by the number of total possible outcomes. It's represented as a fraction, and that is how we determine the probability of an event. Let's apply what we just learned about probability. Suppose a single fair die is rolled. Give the probability of each of the following events. The die shows an even number. Well, again, if it's a six-sided die, then the numbers 2, 4, and 6 would be even. That's three numbers that are even out of a possible 6 sides. And we always want to reduce our fraction when we're dealing with probability, and so that would be a 1 out of 2. The die shows a number less than 10. Well, there are 6 sides on a die, 1, 2, 3, 4, 5, and 6. All of those are less than 10 out of a total possible 6 sides. 6 out of 6, that equals 1. So that is a certain event. Remember that when E equals the sample space, then it is a certain event. The die shows an 8. There are no 8s on a 6-sided die, so that would be 0 out of 6, which is 0. The probability is 0. The die shows a number greater than 4. Well, how many numbers on a 6-sided die are greater than 4? 5 and 6 are greater than 4, so that's 2 numbers that are greater than 4 out of a total of 6 numbers or 6 sides. Again, we want to reduce our fraction, so that would be 1 out of 3. The die shows a 1 or a 6. So it could be a 1 or a 6. That's 2 different possibilities out of 6 sides. So again, that would reduce to 1/3. And the die shows a 1 and a 6. Well, there is no side that has both a 1 and a 6 on it. So that's a 0 out of 6, which would be 0. Now let's talk about probability using cards. A standard deck of cards has 52 cards in the deck. There are 4 different suits, and there are 13 cards in each suit. Half of the cards are red and half of the cards are black, which means that 26 are red and 26 are black. So let's find the probability of each event. What is the probability of drawing an ace? Well, like I said, there are 4 different suits, so there would be an ace in each suit. So that would be 4 aces out of a total of 52 cards. And like I said before, we always want to reduce our fraction, so that's 1 out of 13. The probability of drawing a face card. So a face card is a jack, king, or queen. So that means each suit has a jack, queen, and king. I told you that there are 4 suits, so if each suit has those 3 cards, 3 times 4, that's 12 face cards out of 52 total cards. And that would reduce to 3 out of 13. Drawing a spade. That's one of the suits. So there are a total of 13 cards in each suit. So that would be 13 spades out of the 52 cards. And that would reduce to 1 out of 4. Drawing a spade or a heart. Okay, so if there's 13 spades and 13 hearts, then we could draw 13 spades or 13 hearts. So that's 26 out of 52, which reduces to 1/2. Drawing a spade and a heart. That means they're both on the same card, and there are no cards that have both spades and hearts. So that would be 0 out of 52, which is 0. All right, the probability of drawing a jack. So there would be 1 jack in each suit, so that would be 4 jacks out of the 52 cards. And that reduces to 1 out of 13. Drawing the jack of diamonds. Okay, so that's just the jack of diamonds. So there's only 1 jack of diamonds out of the 52 cards. And that can't reduce, so that's a probability of 1 out of 52. The properties of probability. The probability of each outcome or event is a number between 0 and 1. So remember, if it's a 0 probability, that just can't happen. That's an impossible event. 1 is a certain event, so your probabilities have to fall between, or they can include, 0 and 1. They have to be in between 0 and 1, but 0 and 1 are included. If you get a probability and it's a negative number or it's greater than 1, then you've done something wrong. The sum of the probabilities of all possible outcomes is 1. If we add up all of the possible outcomes, it's going to equal 1. The relative frequency property is found by drawing on past experience. So this table gives the frequency of households having an average monthly electric bill in various dollar amounts from a portion of the respondents of the 2007 American Community Survey conducted by the U.S. Census Bureau. We are to find the relative frequency probability of having a monthly electric bill between 0 and $49.99. So if we look at this chart, the monthly electric bill between 0 and $49.99, the frequency of that is 270. Okay, so if I write 270, that's the event, but we need to know what it's out of. So we're going to have to add up all the total frequencies. So if I add up 270 plus 253 plus 203 plus 112 plus 71 plus 34 plus 57, I get 1,000. So that would give us the probability of having the electric bill between 0 and $49.99. And remember, again, we want to reduce that. Okay, so we could take out a 0 out of both and we would have 27 out of 100. So we can also write this as a decimal, and that would be 27 hundredths, which would be 0.27. Find the relative frequency probability for event B of having an average monthly electric bill of $250 or higher. Okay, so this row is people that have a monthly electric bill of $250 to $299.99, and then this next one is $300 or higher. So we're going to take both of those frequencies because or, remember, it includes both of them. So that would be 34 plus the 57 over all the possible frequencies over 1,000, So if I add those together, I get 91 out of 1,000. And that gives me 91 thousandths. I hope you enjoyed this video. If you did, make sure that you share it with a classmate and be sure to subscribe to my channel. Thank you for watching.